time is it? Ugh. Hold on. I can't even see stream chat. Mute, mute, mute. Okay. Let me get stream. Okay, delete Spotify and let me put stream chat. All right. All right. Let me hop onto the code. Let's see what I did so far. When was the last stream? Okay, it was stream 6. And what I did since then was function type inference. Is that right? Yeah. So I did. Let me zoom in. Yeah, so basic type vars and unification. So that was function calls. That was function calls. And we did unification of arguments, but not unification of the return value. And I'll go into how calculating the return value is done before. Yeah, so I did function type inference, yeah, inference routines plus changes to undefined. That was what we did last time. And the checker, clean up type violated code and fix bugs. Yeah, yeah, pattern matching tuples with upvalues. Yeah, so I implemented tuples. I'm just trying to find out what my stream quality is so shit. Okay, it's not bad. Okay. All right. Okay, I'll go over the changes. So I just showed those changes there, and I'll go over changes to first. I'll go undefined. Okay. All right. All undefined does is return the undefined type. Here, I'll show you an example. This is a difference. All right, let a equals undefined, and then we'll make that a mutable value. Okay, no, and not MPV. Okay. Well, this raises an error because type annotations needed. Amy says, "Yay, I finally caught a stream." Oh, thank you. Welcome to the stream. All right. Yeah. So we're assigning a undefined. Obviously, we're not giving it a type, so it's going to raise an error when it gets to the end of the scope. Type annotations needed, and that error is raised here. At the very end of a scope, that's C scope leave. It runs through all unknown vars, and then raises if type kind equals type var. It gives you type annotations needed, and that catches this, and it also catches things like this. Add equals a, b equals a plus b, and we're not assigning a type to it. It's gonna raise an error for this, and then raise an error for that. And that's how it catches things. Amy says, "Love your VODs." Thank you. Thanks. Hopefully I'll get this VOD out, and then I'll also get some more short content, since the algorithm loves that. Okay. A is undefined, right? It's supposed to raise an error, and it does. And let's reassign it to an I32, and done. It gets assigned type of I32. But what happened last time, and how it was implemented before. So in the parser, it goes like tuck undefined. Yeah, undefined is implemented as just returning a node undefined, right? And then when we get to the checker and we start type checking the node tree, we get to node undefined, it returns type undefined. And that catches a lot of things. How it was implemented before was instead of returning this, what can I do here? Can I do like get blame? No. Anyway, what this did before is that instead of doing this, it returned like a type var new. Yeah, it did that instead. And what would eventually happen is that, let's say a is a type var, and then you add a plus this. Like, it wouldn't really raise an error before, and you wouldn't really know that that type var came from an undefined. So what I do now, and what the Zig does, is they just return a type undefined. And when we get to here, yeah, a plus 20. Okay, that's one of the, okay, I think this is one of the side effects of my unification. I could do something like SL type mismatch. Yeah, okay. What this would guard against is, let's say you have undefined and then plus 20, it should raise an error here. Type mismatch. Expected undefined got I32. In Zig, if you tried this, and let me bring it up right now. I'm gonna godbot. Okay, let's go Zig. It's my favorite website. Var a equals undefined plus 20. Ooh, unused local variable. Okay. Do this. Yeah, okay. Raise an error. Use of undefined variable here causes undefined behavior. And how that's known is because undefined returns a type undefined and not like a type hole, right? If you were adding this to this, it would unify, and then this equals this, and you'd have a ton of errors, right? To catch things early, and to realize, and to let the checker know that this type undefined came from an actual undefined value, it returns type undefined instead of a type var. Yeah. So right now it doesn't raise an error. It doesn't say type undefined. It doesn't say like this is undefined behavior. It'll just write type mismatch. And I'm gonna change that error message to something nicer, like this thing will cause undefined behavior. And we can do that now, even. Yeah, let's do that now. It's in C unify. There we go. I think this is in C infix. Anyway, you know what? I'll do it later. Doesn't Rust also do that? Yeah. Yeah, it does. It does. But it doesn't have Rust doesn't have a an undefined keyword. Yeah, I'll show you an example. Rust doesn't have an undefined keyword. It only has variables that aren't initialized. So we'll go here. Right? You go here, let a, and then a plus 20. It won't raise an error. It would just say type annotation is needed because you're trying to use a value of a. I mean, you can add a type annotation like this. Right? I'll add that. Yeah, used binding a isn't initialized. So in my language, all values must have types, so you can do it must have an initializer. So you can't do this, right? If you wanted to do this, if you wanted to do this thing, you would have to assign it undefined. None for option. No, so this is actually uninitialized memory. There is no none or option. These things aren't being initialized at all. If you initialize it with none, like this, you're actually initializing it with a genuine value. It's not undefined memory. Anyway, basically the whole gist of it is that node undefined returns type undefined, which is a genuine type. And when you try and add this genuine type undefined to another value, so you try and add type undefined to I32, this will cause an error, and we'll be able to catch it. That's one of the better things about that. Instead, before, type undefined, return just type var. Yeah, and that was bad. What we want to do, though, is we want to keep that behavior. So what we can do is go to C pattern. Okay. Let me walk through how variables are defined. So we're obviously assigning a variable like this, right? And it'll get to here. Load node let decal. Node let decal. Yeah. So how node let decal is actually implemented is it's just where is it? Yeah, it's just a pattern and an expression. So here is the pattern, and this is an expression. And when it gets to here, it type checks the value of the expression. So expert type is undefined. Yeah, expert type is type undefined because it'll type check the right-hand side, and then it'll feed in that type into pattern. And the pattern is not a tuple, it's not a tuple unit, it's a var. And this type is type undefined. So if the variable type is a type infer, and this variable does not have a type, so it is type infer. And if the type being passed in by the expression is type undefined, the type is a new type var, and we're going to register it with the inference. And when it gets to the end of the scope, all the registered variables inside this inference thing will raise an error, type annotations needed. That's why it raises an error right here. See, type annotations needed. And if you want to give it a type annotation, you would assign it a value, and no errors. Good morning, you have a unique accent. Unique accent. Yeah, I'm from Australia, Sydney, Australia, but I don't have like, I'm not like hardcore Australian. Fortunately, because they sound really weird. Okay. Yeah, so let a equals undefined. Now, let me find out what else I did. Yeah, function type inference. Now, I'll go over that, function type inference. Let's do an example. I32, actually, no. Yeah, add takes in x and y and returns x plus y. Right, this makes sense. And when you run it, it'll raise an error. It'll say here type annotations needed because you need type annotations. So when you're calling it like this, you don't need annotations anymore because it's the first time is being used. Amy says, "Oh my god, I'm Sydney, Australia." It could be in the same. Wait, what does it say? And I'm in the same year as you. Why are you streaming at 11? Why am I streaming at 11? Why not? Really, I procrastinated the whole day. Well, I wasn't procrastinating. I was actually writing a lot. Writing a shit ton in here. But you know, I decided to stream at 11 because usually the streams are 2 hours max. It'll probably be one when I finish. And I don't know. I don't know. I'm guilty. Whatever. Should be fine. It's the holidays, so I can do what I want, really. Okay. So obviously you're using add for the first time. It'll call it with 20. You're unifying it, and then you're calling it with 30. You're unifying the second operand. So when it gets to here, you have the you have this operand. You know that's an I32. You have the second operand. You know that's an I32. And using the argument type, you can start type checking, and then use the return value of this expression as the function return type. So I'll show you how it works. So yeah, we're only applying it once, and then you can see here that this operand is an I32. We apply it a second time. The second operand is a I32, which means we have both the argument types, and then you return I32. What do you use to show Spotify on the top right when changing the music? Greets, by the way. It's called Dunst. Yeah, it's just called Dunst. What's it called? notify send. Yeah. I don't know. All I did was just install it with Pacman. Dunst. Yeah, it's just called Dunst. It's like the bug standard thing that you would find at every single like minimalist Arch install. Uh, it's always Dunst. It's just a notification bar. So let me bring up Spotify right now. Right, and then just click something else. Click something, and all it does is just show notifications. Right, only Spotify works. But did you configure anything for Spotify on Dunst config? No, I didn't configure a single thing. All I did was install it, and for some reason, it launches when notifications work. I think in the man page for Dunst, it says here, yeah, auto starting Dunst. On most installations, Dunst should automatically be started by dbus when a notification is sent. What Spotify does is just send notifications to dbus, and it auto starts Dunst, which is actually great. It's one of the nicest things I've ever used. Okay, yeah, it's really simple. It's like I could go through my Arch installation right now. It's like 6 things that I installed. It's like 6 things. It's yeah. I used to have there's old VODs of my old setup, and it was just the most convoluted thing with Arch. It was so messy. So I reinstalled the whole thing, and we just have like right now I just have i3, and that's it. Yeah, it's a daemon, so it runs in the background on startup. Ready send, but ignored if you don't. Yeah, it'll be ignored if you don't have it. But if you just install it, it can be used. All right. Where was I? Okay. This function has 2 arguments, right? So if you apply it with 2 arguments, you know the type of those 2 arguments, and then you can start inferring the return type. DWM. I think I tried DWM. Oh, I tried DWM. I didn't really like it. I didn't like it. I3 is just easiest for me. Like I don't even know any of the keybinds. Okay. Node call, right? And this is how it works. You're essentially unifying the argument with the you're essentially unifying the argument of the function with the argument of the expression. And I think I went over that last VOD. It's really easy. All it was is if you have a type var on one side and a genuine type on the other side, and you unify them. So here, a call of add add 20. It's essentially you're unifying the type of unknown with a type of u32. Yeah, and then eventually the substitution is this equals this, which means this is how you find the type of the first operand, right? It's super simple. So FPLC is your language. It's an acronym, Functional Programming Language Compiler. I can't names suck. I mean I can't figure out any names for the life of me. That's why it's called FPLC. Because like originally I wanted to figure out a name before I started streaming, but I just gave up. Really, FPLC is easiest for me because it's just Functional Programming Language Compiler. It's a nice acronym. It's not the name of anything. Okay. Yeah, so you're calling add with this, and you resolve the types of the 2 operands. So here, and then if the type kind, the d function return equals type var, which means you've exhausted all of the return values, and you've gotten to you've exhausted all of the curried arguments, and then you've gotten to the return. So let's say like when you get to here, the type of add will be i32 unknown, right? So the return value is unknown. And it'll check for that. If the return value right now is unknown, it'll get the inferred value, so it'll call cinfer get. It'll find the entry in the list of infer variables. So it'll find this is the type and the definition. And then cool, I'll get back here. Yeah, so it'll find the infer variable and then call C function calculate return, right? And how it works is that it just goes when it gets to here, it goes back to the start, and then starts inferring the return type. So here, where's node? So it turns the function arguments into a tuple. So let's say you have i32, nothing. It'll turn function arguments into a tuple, so i32, and then the return var will be this. So it separates this into this. And what we do with the arguments tuple is we use that to check the patterns. So this is the first pattern. This pattern here takes in a tuple of x and y, and it'll unpack them. And that makes sense, right? And then here, for every single expression, it'll go here, return type, and it'll just take the type of the expression here. So you're passing it in i32 and i32. An i32 plus an i32 equals an i32, and you get the type in here. And so this will just replace the type var, and it'll work, and it'll assert if the type equals different type. Let's say you have something here, you had a second parameter, so which is false for some reason. Here, you get like a do this, double that. Let me get the error here. Oh yeah, let me delete that. Yeah, and it'll run an error here. So it'll type check this. It'll determine that the type of add is an i32. It'll get to here and check the second pattern. The pattern will match because it's just an underscore. And then it'll check the value of the right-hand side expression. That's a boolean. It'll check expected i32 and got bool, and that makes sense, right? This is how that's how function types are essentially inferred. And we did most of the legwork last stream. Since you're adding two i32s, isn't there a chance of overflow? Yes. Yeah, there is a chance of overflow in this language. But right now, this is just type checking. This is just type checking. It's not actually evaluating anything. When we get to generating code, we can take the Rust path, and we could create runtime errors. The Rust and Zig path, we can create runtime errors. Or we could use C semantics and leave the addition of signed integers undefined, so you can add more optimizations. I'm more inclined to go the C route, the unsafe C route, where overflow happens, and then probably add like specific types that raise errors on overflow, because I don't like incurring a cost where it's not needed. This language is going to be very similar to C. It's like a functional C. It's not going to do things like it's going to be quite safe. It's going to be quite safe. I don't really think you should raise an overflow error on every single addition. That's just my opinion, though. Okay, so that's function. That's function. So yeah, so function type inference routines plus undefined fixes, fixed type violated code, fixed bugs, unification and infix, pattern matching tuples without values. Okay, so I did tuples. Let's say let a b equals 1 and 2. All right, we run that, and I mean, then this makes perfect sense. So the 1 and 2, they're both i32s. They decay into an i32, and the return value gets unpacked, and then a is an i32 and b is an i32. I mean, that makes sense, right? And what you could also do here is you can define b to be a u8, and then it'll pass the type of b up the chain, and then it'll coerce 2 into a u8. And that's also quite intuitive. You can even do things like i8. Yeah, it'll so you can this is how tuples work in this language. What you can also do is you can match on the empty tuple, and this will raise an error. Type mismatch expected empty tuple when you got i32 and i32. So what you're supposed to do is you're supposed to put nothing, right? And that makes sense. So you're just matching on nothing, and that's basically what I did for tuples in this language. So it's just tuples here and here. Yeah, so just a 20. And that's supposed to match to, this isn't actually a tuple, it's a single expression. All right. Well, that's basically what I did over last stream. Okay. Are you transpiling to C or are you compiling to x86 or something manually? Okay. I'm going to go over my compilation strategy because this is what I've been what I've been trying to figure out for a very long time. All right. Compilation strategy. Yeah, so here's the optimizations page. I have a whole ton of resources on everything, but this is the most important part, compilation strategy. Where's here? Oh, there's so much stuff. Where's the first thing that I ever wrote? Here you go. You know what? Yeah, it's easy. It's easier to just go up to the top. Okay. The front end generates HIR, right? HIR stands for high level IR. And it's here, right? It's all defined here. All these nodes here. Essentially, you can think of the HIR as an AST, as an abstract syntax tree, right? So you'd get A plus B, and it'll be a tree, right? So it'll just be like plus A, B. So just think of the HIR as a tree. And the reason why I chose a tree, initially I did not choose a tree. Initially I chose an SSA statement based thing, right? But a functional programming language, it's not structured at all. A functional programming language is not imperative. And a functional programming language is based on expressions, right? So it's only fair that you don't write statement-based code like in C, like these ints, right? Code in functional-based programming languages are supposed to be nested. So you have these do blocks, and then you have these and all these nested things. It makes a whole lot of sense to use an AST as the first initial code generation all the way through. Okay, so the front end generates a HIR, and that's the parser. And if you go to the parser here, all it does is it creates these IR node T's. Yeah, it creates these IR nodes T's. So it's expression based, and it follows the source code lexically enough, like decently enough. It still takes liberties sometimes, and the front end also generates sometimes it's desugared as well. Yeah, so it's expression based and lexical enough. It's based on lexical bindings with closures still sharing the same lexical context. So it's things like this, right? Let's say like main. Let me type main real quick. Main equals do. Yeah, main equals do, and then you can also define functions in here. Let's say v equals 20, sum equals x, x plus v, and when I run this creates a closure. But unhandled node kind one. Okay, let me just fix this real quick. Let me just fix this. What is I don't know what node 1 is. Okay, fuck it. Okay. Yeah, it's based on lexical bindings with closures still sharing the same lexical context. So when you get to here, it'll essentially be a tree. There's no difference between closures and everything. When you get to here, it'll reference v here. So that's it's a lexical tree based thing. So it's easier to type check and desugar on. Control flow is represented with expressions, and early termination of the control path is represented with no return. So let's say you do, and then return. The value of do is no return, so you know that control flow returns early out of do. Yeah, so it's easy to type check and desugar on. Will only lower expressions that are used and things like that. Okay. And then lowering generates LIR, and that's lowered IR. So it's low-level statement SSA control flow graph like. So if you've ever seen Rust, I'm gonna godbot. If you've ever seen here, and then let me add new Rust MIR. Here. This is Rust MIR. If you look it up, it's really nice. It's a really nice thing that they did. it stands for mid-level IR, and it's a bunch of basic blocks. It's a control flow graph. I don't think it's SSA. It's not SSA, but yeah. So lowering generates LIR. So all of this, the entire expression-based goodness that we had, this the tree of expressions, it all gets lowered down to this flattened statement by statement by statement. So let's say you have like a if cons, then a plus 1, a plus 20, else a. It'll generate something like this, let a, and then if cons go to b0, else b1, and then b0. No, to use go to is like b0, a r equals a plus 20. b1 r equals a, right? So this is how a compiler would take this code and convert this into statement-based go-tos. And this is what it'll go from here to here. It'll go from expression-based tree to statement-based go-tos and control flow graph. Yeah, so pattern matches are lowered into just if conditions and comparisons. It uses a different kind of type system. It's all structs and unions all the way down. So this is very similar to C. Structs will have their fields reordered, like in Rust. The size of closures are unified. Function pointers are explicit. Closures are explicit. Constant evaluation is performed here. Large amount of desugaring is taking place, and closures are declosurified and optimized here. And then CodeGen creates RIR, like I think like register IR, but that's I haven't completely standardized that in my head. Anyway, what you want to take from this is some very simple things. The front end is an AST. It's a big tree of expressions, right? And this is how you represent functional code. And the second thing, LIR, this is basically C. We're basically desugaring this expression-based code into C, right? And here you go from the C-like code into registers. So it's just a 3-step process, and that's the best way. What I wanted to do initially was only have this and remove this, right? But that's not right. There's lots of optimizations in this language that would benefit from having another step. So closure operations, reordering things, like things like loop optimizations, they would benefit from this. Yeah. So to answer your question, initially, yes, I will be transpiling to C. So I'm gonna implement this. This is what I'm implementing right now. Type checking is done over this. And next I'm gonna implement this. I'm gonna implement desugaring this language, like compiling all the if statements into control flow graphs and everything. And when I get to here, this is perfect code to not generate x86 on. This is perfect code to generate C on. And when I generate C, I can essentially be done with the Bootstrap compiler. When I generate C, I can rewrite the compiler and then start implementing here, RIR. Yeah. Yeah, so I'm gonna be my goal right now is to generate C. I generate C, I'm done with the Bootstrap compiler. I'm completely done. I don't need to do anything else. How are you so organized? It's crazy. The power of obsidian. You know, I used to have every single thing in one file. This was the original pitch. Think of this, but like 9 pages, right? I eventually did put everything in here. It's still a big mess. Zebnus Naga 3 says stop using helix. Yeah, do you know what? I write how I love using helix, and I love it because I use it all the time, just for small things. But for a big project, especially when I'm using Clang, like Clang D, and just like searching things, multiple cursors and everything, Helix has all of this, but VS Code has things like Git integration, and you could also go back in time and find the old files. If I'm working on a big project, I'm going to use VS Code. Yeah, and aymeey says, so it basically just unwraps the functional blocks in the simplest statements. Yep. Essentially, think of it as you're going from Haskell to C, and then from C to assembly. That's I blabbered a lot. I could condense this a lot easier into something a lot more digestible, but I think this makes a lot of sense. How do you survive without Vim binds? Okay. Trust me, it's all you need in VS Code is Control Shift Up arrow, right? Control Shift Up arrow and then Shift Control arrows. This is what I do, right? I want to indent everything. You do this, right? I want to move something. You can do Control X to delete a whole line, and then move your cursor up here and then paste it. And then you can do this. You can do things like that. If I wanna move a line, you can do that, and then unindent like this. I really don't lose a lot of time. Like I mean, what if I wanted to hoist this expression out? I'd do this. R equals this, and then replace that with R. Right? It's really you really don't lose out on much productivity. I mean, as much as it's nice to have Vim binds, like especially like these really nice Vim binds, you don't have to use them if you're fast with the keyboard, right? You don't really need them. VS Code has their own things, right? All you really need is Shift and move the arrow keys to highlight things, Control Shift to highlight a lot of things, and then Control Shift Up arrow to make a cursor. And then you can combine them all, right? Let's say I want to select all of the white space, Control Shift Left arrow. Delete all the white space, I want to delete them. I want to indent, I just press Tab, right? And you want to highlight a lot of these things, you want to unindent, Shift Tab. Tab again. Right? It's trust me, don't feel the need to learn Vim, really. You're like, I mean, it's nice, it's really nice. Vim is so nice for editing just configuration files, or I'm SSHing into a server and I'm using Vim, right? It's super nice. Well, I'm not using Vim, I'm using Helix. Same thing. It's really nice, right? Having this modal binds, it's so nice. But if you're working on a big project, I mean, you don't have to care. Like, at the end of the day, you can just use VS Code and just shift arrow everything, right? Shift arrow everything and you get the job done. That's just my thoughts. That's just my thoughts, really. I've gotten this far. I mean, like if I want to just, I mean, I use the mouse where I need, but most of the time it's just Shift arrows, right? And then move selection up, and then you can do Control Shift Enter to enter rows below. I mean, that's better than Vim. That's less keys than Vim, less keys than Helix, right? Just it doesn't matter what you use. Doesn't matter what you use, really. Okay. I think I can get into what I actually want to do this stream. Good talk, but yeah, I'll get to the type checker. This is what I want to implement this stream. I want to keep fucking scrolling. Here. So I want to implement slices and arrays, slices and array unification, and I think we'll get to this in this stream, right? When I say slices and arrays, I just mean arrays, right? We'll get to array types and like taking slices, and we'll do that this stream. So slices and arrays and slice and array unification. I won't explain the special unification rules because I wrote about them. I wrote about them here. I mean, array unification. This unifies with this, therefore this is that type. You know what? I'll talk about them later. All right, I don't want to get into them now. Okay, well, first step. Let's touch the parser. So a equals 1, 2, 3, 4, 5, and the type of a will be known to the parser. Will be known to the language as this, right? It'll be the type of a array. So let's say b equals this. The type of an array is the value of the first of the what's it called, the first expression, right? So let's say 1 was a U8, B is an array of U8, right? Makes sense. Yeah, I mean, it makes sense. So yeah, so the first expression is 1. 1 decays into a U32. That means type of the whole array is a array of U32s. Simple, makes sense. All right, let's go implementing it. I'm gonna run it like this. When the expression parser will parse this as an A, it'll get to here. It'll parse the right hand side. It'll get to here, and that's unknown. So the array keyword is not known. So let's copy this. Go to the parser, find where that is. Here, p unexpected, expected expression. So let's write it. We'll put it right next to the parentheses code. Okay. Case talk o square. Yeah, this is what I use for square brackets. Case talk o square. All right. Lock t o lock. So this will be the location of the first square bracket, and then simple. All we do is let me just copy this code here. All right. While the token kind is not the closed square bracket, c square. Node t equals node equals p expr. Okay. And then you can do expected comma or closing bracket. Does not equal talk. What's cpa? Yeah, talk. Closing square bracket. Okay. I mean, and you can take a look at this. I mean, it's quite intuitive. Let's say you do 1, 2, 3, 4, 5, close bracket. And then while the current token.kind is not the square bracket, actually, you probably want to do p next. Okay, yeah, so after p next, when you get to this while loop, you'll be here. The first expression here is 1, so while the current token.kind is not a square bracket, it'll parse this expression. So once this expression is parsed, node will equal 1, and the current token will be a comma. So if p.token.kind equals comma, it'll go to the next one. And then it'll loop all the way over again because the current token.kind is not a square bracket. It'll go here, parse the p expr. It'll go to node 2, right? And go all the way around until you get to here, right? And then you have all of these nodes. You have all of these nodes, and then right now you're at node 5, right? You're at node 5, and then the next thing, else if p token.kind equals not square bracket, it is, so it'll just go to the next one. And then while p.token.kind is not square bracket, it'll close out here, right? So it'll go from here. Yeah, so essentially it starts here, and then when it ends here, right? And what you would want to do is p next, right? So it goes after. All right, so this is how we're gonna do it. Node t array is nodes. That is null right now. And then r push nodes node. And where am I getting r push from? I'm getting r push from stbds. It's a single header library that provides easy to use dynamic arrays and hash tables. Super easy. What about multi-dimensional arrays? Would you use recursion? Yes. Expression parsing is inherently recursive. So how it would work is it'll call p-expr. I mean, yeah, how it works. I mean, it's super simple. This whole thing is treated like an expression. It'll get in here. It'll parse here. It'll get to here and go like, okay, let's start parsing the next expression. And then it'll start recursing and then parse the whole thing. That's how multi-dimensional arrays work. So, I mean, this function is called p-expr, and this is how you parse expressions. Inside the array parsing code, it calls p-expr. So this is a recursive function. So it'll continually recurse. I mean, it could even be like this. I mean, this is how you solve everything in compiler development. Recursion and trees. Okay. Now what we want to do is what's it? we have upvalue? No. Okay. Good. I mean, this is the easiest thing in the world. Now let's just create a node for it. Okay, we'll go here. We'll put it right to tuple. Okay, node array. Array literal. Array fine. Just node array. Node array. I don't want to write node array literal. Actually, I like it better. Node array literal. Okay. And then where do I write? I'll put this next to integer literal. Where's detail? Okay, I'll put it here. Okay, struct. We'll create another member of the union, and we'll name that d array lit. I do d underscore after every union member. That's just my convention. Spy says, do you have a recursion limit? No, I don't have a recursion limit. Everything, this whole compiler depends on the fact that you're always going to be compiling it with fsanitize. It does not do any bounds checking. It does not do any null checking. It does not do any kind of allocation failure checking. It does not do any of that, right? Because it's a bootstrap compiler, and I don't really care. So no, I don't have a recursion limit. The next compiler, I'm going to put nice error messages in, nice error checking, nice all of these things. I mean, how I call errors in this compiler is I just do a long jump. Let me go to error. So when I call error with pause, it's a macro that expands into print, and then it expands into error unwind. And then all error unwind does is just do a long jump. I mean, it's dead simple. It's dead simple, but it works. Yeah, so if set jump and then continue. I mean, where is it? Yeah, I just do set jump a million times. It solves my problems. Because it doesn't have to be anything fancy. Okay. Let's continue adding the node. Node array. Yeah, node array literal is here. So all it is just an ir node t of lms. Simple. And if null, the size is 0. Yeah, nice. Push complexity to a more convenient place / stage. Yeah, I mean, a functional programming language is a compiler's language, right? You write compilers in a functional programming language because it makes sense. I mean, what I don't want to do is I don't want to write a compiler in C, right? I chose C because I like C, right? But what I want to do is I want to be over and done with it, right? I want to be over and done with it as soon as possible, and I get into my nice functional language where I can have fun, right? I can have fun writing the compiler. And all the lessons I learned from writing the C compiler, I'm obviously not going to repeat them in the functional compiler. It's super nice. It's a super nice way of doing things. I mean, you don't have to do everything right the first time. You just have to do it to a certain level. Okay. I mean, this is all the array is, right? It's d array literal, and it's a node of elements, right? It's just a list of elements, and it's null if the size is 0, but that's just a convention for the stb arrays. Okay, just simple. Where is it? Node equals, yeah, just fill it in. Yeah, node array lit d. Yeah, nodes. I mean, that's it. All we did, we just finished it. I mean, that's done. We're done. I mean, we just finished. And then, so this is how the parser works, okay? And then do this. Unexpected that, expected expression. Huh. Why is that? That should not be like that. Where's that coming from? Okay, this is rare. This is rare. Run b. No, run. Oh wow, am I getting an overflow? No, I'm not. Okay. Oh, p top statement. Okay. Yeah, statement calls p expr. I don't know why it's getting down here. Ah. Okay, I know the issue. Let me just implement it real quick. Okay, this will all make sense. Okay. All right, let me explain my logic. Let me explain what I just did. Okay. B equals f of x, right? Obviously, this makes sense because you're calling f with x. But what if you're doing something like this, right? You're parsing f, right? F is being parsed. It tries and peeks to the next character because it's trying to parse a function application, right? When it gets to here, it raises an error, right? Because you're trying to get to here, you parse an expression, and then you start parsing another expression, and it raises an error, right? Because comma is obviously not an expression. So what I do is, when I parse an expression here, I recurse and I return something. What's it called? Yeah. So when I call a parse expression here, you're parsing the expression with px per et paren, which means when you finish parsing and you reach here, it will not greedily search for the next expression to parse. Yeah, so it just lets it know. It just lets it know. It's like a stop key. It's like a stop token. It's like a stop token. So when I'm parsing this, when it gets to here, I do not want it to parse again, right? Because when you're parsing this like this, you're calling one with one, but you don't want to end up going to the next token and just trying to parse, right? Because the comma isn't an expression. So what we do is we feed it config. So I'm calling it with config px per et array. So when it knows to stop when it gets to this token or this token. Oh, okay, no, this is right. Yeah. Anyway, so what I just explained is a quirk of functional languages, especially ones that don't use this the parentheses calling syntax. They just use a as being b is being applied to a, right? This is just ambiguities. It took me a lot of trial and error to actually get a robust expression parser, but so I'm pretty proud of it. But anyway, all that matters is that we've parsed an array, right? So we parsed the array, it's a node. What we need to do now is do type checking. So this is what happens when the type checker gets to a node it doesn't know. It raises an error, it goes unhandled expression kind 18. I print out a stack trace and it gets to here. All right. And the error is in this function, cexpr, which stands for check expression. It checks the expression inside this thing here. Right, and it gets all the way down here, which means default unhandled expression kind. So now we're going to handle it. Case node array literal. And now what's the semantics that I decided on, or we decided on, or whatever. We're all a team here. Is we decided on is it checks the type of the first expression. The type will return it, right? So the type of the first expression is an I32. It'll check the type of the first expression. It knows it's an I32, which means based on the first expression, the whole type of this entire sequence is an array of I32s, right? So if you have one here and you have false here, bool does not equal I32, right? Because you've already determined the type in the first member. So that makes sense, right? Okay, node array literal. We will first assert that the node, let's go expert dot d array literal dot lm is not equal null, right? To do handle this, right? We'll figure out some semantics for empty arrays soon. Okay. To do handle whatever that is, right? Empty array. We'll handle that later. But for now, if it's not null, we know it has at least one thing. So yeah, that sounds good. Okay. So ir type tlm type equals c. You're calling a c expr. So we're gonna pass in the scope no upvalue for now. Explain those in a bit. Yep, and you're calling it with the first operand, right? Yeah, I'll take a good see that. Okay, so this is the member type of the thing. So essentially, it's just this element type. Okay, and then what we're essentially going to do is we're going to run through this. It's already filled it in for me. So I equals 1, so we're skipping over the first one. C equals the array of the length of the array in a, what's it called, U? Unsigned in, yeah. Yeah, and we're essentially just going through all the expressions. Yeah, so type t type equals c expr upvalue lm type expr d array lms, and then we're just unifying. So we're gonna unify with let's extract this node t node. What's this? Make that inner. Okay, so we're calling c expr on this, and then we're unifying the right hand side type. I mean that's perfect. That's perfect. Okay. Ushi18 says, "What color scheme is your editor?" Someone gave me a comment about that on the most recent VOD. I haven't answered it yet, and I feel bad. It is Sweet Dracula Monachi. That's it. Sweet Dracula Monachi. It's I mean, it looks nice. I mean, I don't care what. I mean, I say it. I think it looks nice. Super simple, really colorful. You know, that's it. And I'm gonna respond to that guy's comment. Okay, well, what we need to do now is we need to construct an array type. I mean, that's just doing it for me. Yeah, just fill it in. You know, well, this is easier. Ti kinds t info. We'll just construct the type info, and then return type new. Okay. We're creating a new type. This is the type info. Its kind is type array. And then it's just d array, which is just an element and an element type. And it's just we're just doing that. So yeah, we're creating a type with a new type info, which will just be type array, and the it's called element type. Anyway, that should make sense. But we're getting squigglies. I don't know where that's coming from. I don't think I have an array type yet. If not, we can go implement it. Let's do that right now. Okay, these are concrete types. Obviously not doing a concrete type. That's ti kind. Okay. These are the list of types, these kinds types. These are all the concrete types. So this is like the i8s, i16s, i32s, unit type, boolean type, bottom type, type undefined. Chat. Hello. Oh, I haven't seen you in stream in a while. Welcome back. Okay, this is the type kind. Type concrete list. Has all the normal stuff, undefined units, bools, and that's all the types. And then these are the compound types. So these are the type vars. That's the thing we did with unification last stream and this stream. The tuple types. Here, let me show side by side. Place it uses type kind. Okay. Yeah, so tuples are here. This is d tuples. All the tuple is a list of elements. A function type is yeah, the function type is argument and ret. So these are the current representation. So it just has an argument and a return value. And type pointer, that's not really implemented yet. Well, it is, but I haven't done anything useful. Yeah, so this is just a d pointer, and this has a ref to a type. The legendary chat featured in Why I Hate cmake. Yeah, that video blew up. That video blew up like crazy. Yeah, so D pointer is a ref. Spider-Man says why? What part? Okay. We'll do. We'll make a We'll make a distinction here. All right. An array of I32 is a type. An array of 10 I32. These two things are different types, right? This is going to be a type slice. It's going to be type array. Spider-Man says, why do you hate cmake? Okay. I hate cmake because it's too fucking complex. It's incredibly complex. It's like even make is complex. Even make is complex enough, and then cmake it's just another thing on top of that. Plus, I've heard horror stories. I don't even want to touch it with a 10-foot pole. Like make is enough for me. Build scripts is enough for me. I mean, there's a reason why I haven't created a shell script, right? I'm just running gcc global to C files because that's how it should be done, right? I mean, even think of the even the V compiler is its own build system as well. It's not even its own build system. It just has a simple rule: glob all the C files, glob all the V files, right? That's how compilers should work. Glob all the files that you need. I mean, I just don't get why building has to be so complex, right? Building is only complex when you're trying to integrate multiple languages together. I don't understand. I mean, the people who made cmake, they must have been crazy. I mean, I don't. If the explicit type of an array doesn't is a that would be a slice. Yeah. So this is the distinction. This is the distinction I make. An array type with a known constant length, that's a type array. But one without a constant length is a slice, right? This is a fat pointer, and this is just a normal pointer. You should read up on fat pointers. You should see how look up fat pointer Rust and things like that. It was a replacement for autoconf. Oh, even worse. Fuck, autoconf is even worse. Oh man, I hate autoconf. Anyway, this should make perfect sense. I mean, nice distinction. These are slices, these are arrays. So let's just go implementing them right now. Type slice and type array. Possibly, I don't know if I want to. I should probably unify them. I don't know. I don't think I'm going to unify them. Okay. Type slice and type array. All right, and then let's scroll all the way up or all the way down and write entries for them. All right. Struct d slice is just a ref, and then struct d what is it? D what's it called? D array is a ref and a is it? Did I write usize? Is usize a type that I use? I use size t. Leng. Yeah. All right. Well, I'm not gonna do arrays for the time being. Actually, I'm gonna need to. I'm gonna need to do arrays for the time being because these are array literals, which means they have a definitive known length at compile time. Okay. All right. There is semantics on how arrays can decompose into slices, and that's what I wrote here. So if you want to unify an array type with a slice, it'll have to it'll unify them together, and the constant known length is lost. Don't worry about that for now. We're gonna implement that later on in the stream. What's the time? Okay, we got 1 hour in the stream so far. All right, we're making good time. This isn't a hard thing to implement really. Okay. Check type array. Length is this. No one's gonna have an array literal larger than a U32. Okay, might as well just make it a size T anyway. Okay, yeah, length. And then we'll remove this while I is less than length, and then here, I think I'll name it LM instead of ref, because LM it just looks nicer. Okay, LM len type and length. Do you intend to support an any type? No. I really admire the C programming language because you can do everything in the world without templates, without dynamic dispatch, and all of these things. I don't think I'm going to support an any type. Avoid pointers is fine. No any type. I've never felt the need for an any type in a programming language except for printing. But printing nowadays is you expand generically. So that's all templating. I really don't think there's a use for any in modern programming. Like, you want to do something useful. The only places I've ever seen any used is when you're panicking in Rust. When you're panicking in Rust, and you can panic a random value, right? You can panic literally anything, and it has to represent that in a dynamic dispatch type. So that's the only time where any has actually semi-made sense. But even in Rust, when you're panicking, it's supposed to be over, right? You're not supposed to return something useful. So I say any is useless. I say any is useless. I've never felt the need for it ever in a programming language. But I mean, even printing, right? Even printing is handled at compile time, right? You have your list of substitutions in a printf style. You're never gonna need an any type for that. You're never gonna need an any type for that. I think it's pointless. I think any types are dumb. I don't think well, they're not dumb. I don't think they're any useful in modern programming. If you want to get something done properly, they're not useful at all. That's my 2 cents. Avoid pointers all the way, but even then, why would you use a void pointer when you have generics, right? Why would you use a void pointer when you have generics? It's just the little things that make your experience better, and generics is one of them. All right, so we type checked. Let's do GCC this. Okay, and where's the error? The error is in printing, so we go all the way over here. We're done. We finished type checking. Now we need to print. So let's just do some printing. Case type array, and all an array is. You know what I want to add? I want to add braces over all of these, but I'm fucking lazy. My normal code style is braces on all of the cases. Commit. Type debug. Nope, it's the other way around. Yeah. What is a? I forgot what the format argument for a size t is. It ZU? It's ZU. Yeah, I never forget that. Lock here. Oh wow, what's this coming from? Unknown expression kind. Is this type checking? This is dump expression. Okay, we're printing expressions now. What we just handled was printing the type. Now we need to handle printing the expression. Okay, this is simple. Case node array literal. Just fill it in for me. Wow, I mean, that's great. Done. Okay. We've successfully determined that the type of A is an array of ith2s with length 5. Done. I mean, that's quite simple. What I want to do now, though, is I want to integrate annotations. If I write A is a list of U8s, I want every single thing here to be automatically cast into a U8 implicitly, sort of thing. And how I do that, this is bi-directional inference, right? Because type information can flow down, but also type information can flow upwards. And how I do that was actually a it was a technique I came up with when I was writing the V WebAssembly backend, right? Because V did not store the type information on the node; it stored the type information on the parent. So how do you bring the type upwards, right? So I used this notion of an up value, and this is how I implement bi-directional type inference. And let me show you. Okay, so let me just run through it here. You know that A has the type of a U8 array, right? And you'd want to do this as well, like in Zig, to infer the size, but we're not going to do that right now. We're not going to do that for now. But here, I mean, yeah. So you know that A is an array of U8s. So when you get to here, it'll push this type information upwards, right? A is an array of U8s, which means you need to make sure that the right-hand side is of type U8. So it'll unpack the array here, so you know the type of each operand is a U8 here, and it'll insert it here. And here, let me show you. This will probably help you. This will probably help you understand what I mean by an up value. Okay, let me go to this thing. So cexpr does the normal thing, right? It just parses a node, and it returns a type. So it takes in a scope, takes in an up value and an expression, and returns a type. Okay, and what the up value does, all right? Let's say A is a type i32. Let's say A is a U8. A equals 20. 20 won't have the value of an i32. It's supposed to have a value of a U8. So you know that A has the type U8. And then when you run cexpr and you're parsing, when you're like checking the value of 20, it parses a U8 into up value. And so let me show you where that's here. Node integer literal. If the up value is not a type infer and the C type is numeric, if the up value is numeric, the current type is the up value. And that's how I do this kind of bidirectional type inference, right? Let's say you know the type of a thing before you and you want to coerce the type upwards. So you push a type upwards. That's the up value. And then the type still gets returned and you can do normal checking, right? The child can ignore the up value. It can ignore the up value, and then the caller has to handle mismatched types. But this notion of an up value and bidirectional type inference, it's really nice. It's a really nice. This is how I implemented tuples, right? Let A B equals 1 2, right? And then B is a U8, right? How do you know that 1 is a i32 and 2 is a U8? It uses up values, right? So it constructs an up value. Let me show you an example. Node what is it? Node let decal. All right. It C pattern up value constructs the most general. C pattern up value constructs the most general up value for parsing. So the most general up value for this would be a tuple of type infer and U8, right? This is the most general up value. It passes this up to here. It passes this up to here, right? And you now go here, node tuple. Where is node tuple? Okay. So now it unpacks the up values if applicable. So if the up value is not an inferred type, so if the up value is just is an actual type and the type is a tuple, so it'll do up values equals type get. So this will assign a list of up values if they have the same length, right? And then when you're calling a cexpr, when you're calling the individual expressions, it checks if it has an up value and then passes that up value in. So what it does is the most general up value for this expression is type infer U8. All right, and then when it hits the node tuple, and then it does this type infer, and then type U8, right? So it's pushed upwards, this type information, right? 1 gets hit with a type infer. Okay, so the default integer type is an i32. 2 gets hit with a U8. Okay, so we know the type of 2. The type of 2 is a U8. And then now this type information gets passed down. Now this type information gets passed down like this. So now you know the type of this is an i8 U8. And then it does unification, so that means A goes to an i32 and B goes to U8 in the types match. And that's how I do bi-directional. That's how I do bi-directional type inference. It's one of the It's such a simple thing. It's one of the most simplest algorithms. But I mean, it makes so much sense. You don't. I'm pretty sure most compilers do this. I'd be surprised if they didn't, because it's just so simple. This notion of up values that can be ignored, and then the caller has to handle mismatch types. But if you wanna use an up value, I mean, this is where up values are robust as well. Let's say you have 1 and 2, right? And these two types, there is no. It creates a general unifier, which is type the most general unifier. The most general up value is type infer U8 type infer, right? But when it gets to here, they've incorrect lengths. So these will just be assigned i32 and i32, right? It'll just be ignored. So you can ignore the up value. And then the error message is cannot match tuple pattern against tuple type of different length. You know what? Let me print the type as well. Tuple pattern. Actually, no, there is no type to match. Just assume that yeah, I mean, it ignores these types here. It would just go to an i32 and an i32. So this is how I do up values, and what I just showed you here will lead into what I want to do right now. So A is a array of U8, and A is 1, 2, 3, 4, 5. Okay. What we want to do now is pass U8 as an up value here, right? It'll turn into an up value. And then we have the type. And then what we want to do is pass that type as an up value for every single one of these preceding things. Because let's say false is here, right? Or let's say like it's like a string or something. Or like one is forced as an i32. Okay, 1 is forced as an i32. It does not take the type of the up value. Okay, so we know the type here, and then this whole thing is now a type i32. This is an explicit. This is colon i32 is an explicit cast. These are genuine explicit casts. Me using this colon thing, that's not real syntax, but this is real syntax. So the type of this thing is an i32, and when it gets to here, it'll write a mismatch error. But if this wasn't here, this thing will go to here. That means 1 will have a type of U8, and so on, and it'll pass the up value up the chain, and this will be U8, and blah, blah, blah. I've talked for too long. I'll go ahead and implement it because the best way to teach is to show. So, okay. Node array, literal. Node array literal. Okay, don't worry about handling these things, arrays with nothing in it, because I wrote a bunch of semantics here. Okay. Now we want to get the up value. So yeah, this is the up value here. And what do we do for tuples? Okay. Unpack up value if applicable. Yeah. Okay, so what can happen is the up value can be an array of t and also a yeah, so it can either be a slice, that would be a type slice, or a type array. Okay, so what we want to do is we want to respect the up value, because the up value, let's say the up value is a U8, we want to respect the up value. It can either be a U8 or a U8 of a known size. That's an array. So we want to respect the up value. Yeah, so all of these can coerce into this, but this can't coerce into this, right? So, okay. let's try and extract the element type. Okay, so it's type t upvalue lm upvalue equals type infer. So there's no type for the upvalue. Okay. Type kind upvalue equals yeah, and then just switch type kinds upvalue. Case type array. Yeah, you type slice. I'll do nothing. Okay. Why don't you interpret the element as the array's type when explicitly casting an element as a different type? Mirror this. Okay. I think I do that. I do that. So so let's say this is a type of I32, right? The colon operator means cast and then the type on the right hand side. So I'm going to cast this to a U8. That means the underlying type, so the type of the first thing will be the type of everything. That means this will end up as a U8. I do this already. So if you interpret, yeah, it has to be the first element. Why don't you interpret the element as the array's type when explicitly casting an element as a different type? Yeah, I do that. So you can either do it like this, or you can do b because U8, and then you can do b. You do this. So you can have an array like this, and this will be inferred type of U8, or you can write an explicit type, and then it'll do bidirectional type inference and push the U8 type up. And you know what looks nicer? This looks nicer. Explicit types, they look nicer like this. So I prefer this, and I want to support this. But this will also be supported as well. This is the current behavior. But I want it to respect up values. So I want to first extract the element type from the up value if it's applicable. And here, up value. Yeah. Amy says, yeah, but I'm talking about when one element is of a different type to the first element, where you should just interpret that element as the first element's type. Yeah, well, okay, I think you mean more than an implicit conversion, because all of these things are implicit conversions, right? All these things are implicit conversions. The unification function does implicit conversions. But I think, do you mean like a hard cast, like false? Like you want to cast false to an I32? Because I don't want to support that. I want it to be explicit. I want it to. So you can do like let's say this type is a U size, right? It's a pretty big type, a U size. And then V is an I32, right? And then you can put V here. This is valid. This is valid because V can be implicitly casted to a U size. So we implicitly cast an I32 to a U size. Actually, not an I32. It has to be an unsigned. Yeah, so we can implicitly cast V to that. I mean that makes sense. That makes sense because that's what the unification function does. With the unification. Yeah, so we do that. It only so I mean this works fine. This is it does what is it? Implicit cast. So this is an implicit cast. Yeah. Spider-Man says explicit is better than implicit. Implicit is shorter but leads to complexity. That's right. That is right. The array syntax right now is basically taken from basically how V does it. And I really admire how V does it, this syntax. So I don't mind it. Explicit must be explicit, right? There's not many things we do implicitly, except for implicit integer conversions. Only when like their range fits into the next type they're comparing to. Anyway, okay, so we've extracted the element upvalue, and then here, so upvalue is passed in here, and then the element type is always the upvalue of every next expression. So let's say we have 1, 2, 3. Array 0 is type I32. Right, and then you're calling expr with upvalue I32, right? So you're gonna cast 2 to every next thing. Where if this is a this is an array of U8s, 0, the up value gets passed, that means 0 is a U8, that means every up value is this. Yeah, it's just these mini conversions. Okay, so we extract the up value. This here makes sense. Extract the up value, pass it here, and then every next up value is the element type. And that seems it. Let's run it. Okay. Yeah. So A is an array of I32s. I want A to be an array of 5 U8s. Oh, okay. Unexpected expected type and definition. Okay, well, okay, first we need to implement parsing. We need to implement parsing these arrays. Where is it? Go to the parser. How are we doing for time? 1 minute 30. 1 hour 30. Okay. This is parsing tuple types. Okay. Case C square. Was it closing square bracket? Okay. And then how it works is what we do right now is the array. I mean, we're currently in here. Oh, oops, go back up to the top. Okay, and then I'm just gonna copy the code from the parser. I'm gonna go stream, but it was I'm gonna go sleep, but it was nice watching you stream. You know, sleep well. I mean, I'm glad you can come. Uh, I really enjoy streaming. Okay, I'll take this. Just steal the code. Really, nothing important. Actually, no, there's nothing to steal. Okay. Forget what I just said. Okay, we can either have 2 different definitions. So we have 5, 3, 2, nothing with nothing 2. P next. What I want to do is I want to pause if p.token.kind equals tuck integer literal type array. Else if p.kind tuck c square else inspected okay, expected integer or this. Right, obviously we want to token t integer. And then p next, and then p expect. Or extract this to here. What was it? Int size. Okay. Bool is what am I gonna name it? Name it for me. It is slice. It is array. Okay, and then p next p expect. Okay, so right now expect to be here in the token stream, and then we just do p type. Yeah, we're calling p type recursively, and we're parsing the next type. Good, and then we're just yeah, type equals type new. Wow, I mean, okay, thanks ChatGPT. Well, not ChatGPT, Copilot. I mean, endpointer equals null. I mean, we want to get an error. Actually, there is no error. Okay. That's the wrong kind of type info. This is array. Wow, I mean, fuck. This is okay. Wow, and I want to use true. The LM type is this. Well, I mean, it's amazing how much it autocompletes based on previous information. But keep in mind, Copilot's got a lot worse. It's a shadow of its past self. It's horrible, but it gets the job done. Copilot, when it first came out, was amazing. Okay, darray lm. Okay, great. What we do here, we just break because this is a right recursive. Unexpected type and definition. What? O square. Alright, compare type info unreachable. Okay, this is where we do in type interning. Okay, great. Wow, wait, you just did it. Just did it. Okay. A is a U8, 1, 2, 3, 4, 5. Okay. Now what we want to do is we want to remove this and then try and coerce them together. Oh, what? Unexpected U8. Let me fix the parser. Okay, do nothing. Yeah, we'll do that instead. Alright, debug type stir unreachable. Okay, yeah, when you do slices, case type, slice. Good. Alright, now let's do unification. Let's do unification. So type mismatch, expected array of U8, got array of 5 U8. Now this should make sense. You should be able to coerce this to this. You should be able to coerce this to this. And I wrote something. I wrote some stuff about it. This is not very interesting. I wrote a ton here about semantics of what you want to expect from this. I mean, what is this? A equals empty, right? All of this about the semantics of this, not much about the semantics of unification. Okay, this is what I'm talking about. I want to coerce a type of 5 U8 to this. I want to coerce a type of array of 5 U8 to this, right? This seems I mean, you should be able to do this. I mean, I don't see why not. I don't see why not, because this is a a normal pointer and this is a fat pointer, all you're doing is constructing a U8, like a slice with len type U8 len 5. Okay. Chat says, "Are you a fan of the latest C standards?" I love it. The latest C standards are amazing. Let me go C23. Oh my god. I can talk for hours about C23. Okay. C23 is amazing. Not many things get added because it's designed by committee, and designed by committee fucking sucks, but I mean, at least we have designed by committee for C because it's it's important. I mean, big decisions are being made here. So there's not a lot, but what they have here is amazing. Currently, I can't wait to start writing C23. Currently, most of the features of C23 have not been implemented in the newest compilers. Things like type equivalents for like unions and structs, like in a macro. So you can do generics now. You can do generics, type generics in C now. There's also things that haven't implemented. Const expr they haven't implemented right now, which I really want them to implement. I think GCC implements it, but Clang doesn't. GCC implements all this stuff super early. Okay. Let me get to all the things that I love. All right, there's all the things that I love. All these normal things, old style function declarations and definitions, representations for signed integers other than 2's complement. Okay, so all signed integers in C are now 2's complement. Now that's a double-edged sword, because for one, you get no undefined behavior on signed integers, and their multiplications and stuff. But because when you remove that undefined behavior, you remove the ability for optimizations. So now, like, it'll behave more like Rust integer semantics. I mean, it's double-edged sword. I think this is a nice feature. I don't mind it. Yeah, all these things. Static assert becomes a keyword. Thread local becomes a keyword. That's amazing. What else? Yeah, true and false and bool, they all become keywords. Right now, they're not macros anymore. Null pointer becomes something in the standard. We don't get nulls. You don't get these weird integer casts of void pointer or integer cast of pointers now. We can use null pointer, which is great. Yeah, single argument static assert is amazing as well. C++ has that. It wasn't the C standard till now. What else? Stuff for working with bits. So std bit is really nice. I haven't got to the features that I really love. Mem set explicit, it was a really nice thing to have. What is like the most amazing? Yeah, const expr. Where's const expr? You can now have const expr in C, which means let me show an example. Godbot. Let me show you a good example. This just trips up people all the time. Let me go to C. Okay. Hold on. The most annoying thing in the world is Dark Reader. Okay, great. Okay, let me show you an example. Let's say you have an array. So let's say you have. This is what people would usually do. You have int size equals 20. Okay, fine. Int size equals 20, and you have your int array with size. This is a variadic array. You see all the code that got generated? That's because this is a variadic array. Well, not you mean like a variadic array? Fuck, what's it called? An array that doesn't have a size bound at compile time, but it looks like it does, right? It looks like it does. In C didn't really have a way to represent real constants, right? If you wanted to do what I'm trying to do right now, you have to do define size 20, right? And look at all this code disappear, right? I think it turns into a no-op. Yeah, it turns into a no-op. I mean, why don't we have this in C? But we now finally do, right? We now can define constants as constants. I think it's just int const expr int a size equals 20, and I think I need to put on stood c2x. Look at that. I mean, it's just like the define. It's just like the define. That's amazing. So you can have consts. You can have const expr. And another thing that I love about I think I wrote about this. Where's C23. Oh, come on. I surely have standards. Well, I surely have wrote about this. Definitely have wrote about this. This is some C stuff. Here. With a sneak peek into C23. Okay, this is just some designated initializer stuff. Bool and false, they're keywords now. Oh, come on. I know I wrote about unions. I swear I wrote about. Okay. Generics. Here. C23 generic functions. No, so bright. No. Yes. Okay. This is another one of my favorite things that got added to C23. Oh yeah, you can't forget embed as well. Embed hash embed got added as well. Okay. Oh fuck, where is it? Come on, it showed up for a split second. Generic. Come on. When it showed up. Oh yeah, Annex K didn't get removed yet. Come on, it showed up. Ah, here it is, proposal. Come on. Please just... Here. Okay. This is it. I'm really happy N3003 made it. This is the most, this is one of my favorite things. And this introduces things like type generics in C. So let's say you want to define a generic container. So you can define a macro, vec_t equals struct vec this and this, right? I mean, makes sense. You can define this, vec_push and all these things. But what's the most important thing is that here you can write this as well. Here, so yeah, so you can call so you can define vec int x equals this or this in C2x, but it's a GNU extension already, that type of initializer. And then when you do this, you can do address of x. But pre C2x, you'd need to fuck, I'm so bright. Pre C2x, you'd need to type def it to make the pointers compatible. Now, vec int pointer and another vec int pointer, they're compatible now. Here, let me write an actual example because I don't think it might go over people's heads. I'm not explaining it very well. All right, let's write an option type. Option t equals struct option t. T is okay, and bool air. Okay. And then we have a function that returns an option. Option print. Func. Okay, just return nothing for now. Oh, wait. Yeah, so incompatible types from returning option int, but struct option int was expected. So struct, yeah. These are incompatible. I mean, it should be compatible. It is currently incompatible in the current C standard. In C23, they're going, oh my fucking god, so bright. In the C23, they're gonna implement, where is it? I think it's like N3. It's somewhere here. I think it's not type inference and object definitions. It's one of these things. So, it's N232 N3. 3.8. Anyway, it's somewhere here. It's somewhere here. This allows generic data structures and compatible types when you're without a type def. So I don't need to type def option T. I mean, you could write like this: type def option ints. I think this is what they meant. Anyway, it's impossible. Whatever this is impossible. You can't do this. In the next standard, it's possible, which means it allows generics. You can now have, you don't need to type def these things, which is great. This tangent is too long. I'm going to edit this thing down. Anyway, long tangent. This is what I love in short. Okay, embed, you can do embed in C with hash embed. You can now do generic, you can do type generic containers in C right now. Bool, true and false are now keywords. Standard, like static assert is a keyword. Thread local is a keyword. They also added these things, these proper attributes. So deprecated, fall through, maybe unused, no discard, no return. These things from C++, they got added. Null pointer got added. I mean, all of these things are like great. I mean, especially all the designated initializer changes. Anyway, I love C23 and I can't wait to use it. But GCC has an unfinished implementation and Clang has an unfinished implementation, and I can't wait to use constexpr as well. Okay, back to everything. Okay. What we want to do is these types are incompatible and they should be compatible, right? Coercing a U8 of 5 to a U8 slice, that should be possible, right? Because you're converting... I mean, it makes sense because you know the size. What shouldn't be possible, though, is converting a... is going the other way around. This is impossible because you can't constrain its type. Maybe with some if statement guard magic, it's possible. But this is not possible. A U8 to a thing. Yeah, so this is the only thing that's possible. And how I implement that is in unification. So this is where the type mismatch comes from. Where is it? Let's figure out where this type mismatch. This comes in CUnify, right? Okay. And let me go to let decl. This is what's happening. Pattern var. Okay, so we have the left-hand side type. The left-hand side type is a slice of U8, and we have the right-hand side type. This is an array of U8, and that's five elements. So when we get to here, we call CUnify with the left-hand side variable type and the right-hand side type, and then we pass on error. This is where like the on error is a thing. Anyway, we have the left-hand side and the right-hand side, and we want to unify them. So we call unify type, and then unify innards, and this is here. Currently, there's not many things implemented. Right now, if the types are equal, you can return the type. If the left-hand side is a type var, you can replace them. If the right-hand side is a type var, you can replace them, mix and match. The right-hand side, no return type coerces to anything. So if you have a no return type on the right-hand side and something on the left-hand side, you can coerce. And this is what I mean. You have A is a type i32. A is a loop infinitely, and that is a no return. But how the semantic works is that when you unify an i32, the no return coerces to an i32. Because it's an infinite loop, you won't produce the value anyway. So let's do this thing. So if LHS kinds equals type slice and RHS kinds equals type was it type array, and then you would want to if we'll get the both T and first. Okay, if left hand side LM equals this, okay, and then Yeah, so yeah, a type array always coerces to a slice. Makes sense? Makes sense. Let me run it. Wow, did it. Okay. Yeah, so let a equals this, and it goes to that. What I want to do though is I want to add a explicit cast because I want to make everything explicit in the AST. So obviously I want to make an explicit node cast that does this cast, but for now, this unification is fine. To do explicit cast. I mean, that's fine. I mean, done. We did proper unification, so let's check these boxes off. Slices and array, slice and array unification. And we didn't do tuple unification yet. But I think we should close it off now. I mean, I wrote so much on what is actually meant when you do this. I won't get into it now. I don't think it's very important. It's just semantics, really, nothing important. But what we got? Let me do the commit. Let me do the commit. What did we implement today? Oh, not much, but it was a lot of theory. I think I taught you guys a lot about how the internals of the compiler works. Check out. This is stream 7, I think. Yeah, it's stream 7. Implement array of t and unification with unification. Okay. Great. Oh shoot! Fuck, you guys got in my face. Okay. Well, I mean, I think we're finished. I think we're finished for today. Let's go over what we did today. I just did. I just did. Okay, I'll go over what I did in the what I'm going to do in the future. So, this is what I have for the future. Tuple unification. Not that hard, really. I don't think I need to go over this in a stream. Infer most general function type from patterns. That would be a nice thing to show, but it really isn't that hard. Option types would be nice. I feel like I'd get to here. I feel like I want to do this before I do all of these other things. And then initial detriggering. Yeah. Anyway, I may be on my 7th stream, and I may have like spent 2 weeks on this on and off. But there is a lot to implement in a programming language. I'm not just creating another C. I mean, C is easy as hell. This language, there's really a lot to get done, and the type checker is the hardest part. I do the type checker, I can start working on the IRs and everything. It'll be nice. It'll be really nice to finally have my new language. I mean, thank you guys for sticking around. Like, I really appreciate it. It's one of my favorite things. You know, if I want to end up talking to you guys, I might create a Discord server. That may, like, because I want to meet new people and, you know, talk to other smart people, the community. You know, I might want to, you know, just talk about how I'm going. Spider-Man says good night. Yeah, I need to go to sleep. It's 12. Yeah, but I'm gonna go to bed now. Good stream. I really appreciate you guys coming over. I'm gonna go upload this. I'm gonna upload short form. I got these nice things. Chat says yes, you should create a Discord server. Next VOD, you find the VOD on YouTube. I'm gonna put Discord up there. But you know, thanks for sticking around, guys. All right, stop the stream. It's over. Good night. Good night.